Okay, this is going to be on a video on systems on graphing. Okay, when it says solve the system by graphing, the first thing you got to do is get it in y equals. Okay, so this one's already in y equals. That one's good. Okay, this one I would have to move that x over. That would be negative x, positive 8, because I would subtract x. Okay, and then I would divide each part by 2. So this is going to be y equals negative 1/2 x plus 4. Now, what I want to do with these, I want to graph this and I want to graph this. Okay, I want to graph these two things. Okay, so 2x minus 1. All right, so that's right 1 up 1 2, 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 right 1 up 1 2. I'm gonna also go the other way. Down left 1 down 2, left 1 down 2, left 1 down 2, left 1 down 2. And the reason why I want to do this is I want to make sure my line is really accurate. Okay, now this one plus 4, then I want to go down 1 to the right 2, 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 then 1 2 1 2 1 2. Okay, now where the intersection is my answer. So that is 2 over that's 2 over and 3 up. That is the solution. So we're looking for where does the graph cross the x-axis. Okay? This one's already good. This one, I'm going to have to move these two things over. Okay, so that's going to be 4y. If it's negative 12x on that side, it's positive. Negative 24, positive. Divide by 4. Divide by 4. I got y equals 3x plus 6. Okay, so I'm going to graph this. I'm going to graph this. Negative 2, 3 over 1 up. 1 2 3 1 1 2 3 1. Go the other way. 1 2 3 1 1 2 3 1 1 2 3 1. So real accurate line. 3x plus 6. Okay. So that's right 1 1 2 3. I'm gonna go there. 1 1 2 3 1 1 2 3 1 1 2 3 1 1 2 3. Okay, 1 over 1 2 3. Okay, and now this is my line. Okay, so this is 1 2 3, negative 3 over 1 2 3, negative 3 down. That would be the solution. So you want to plot enough points so you can get an accurate representation what that is. Okay, so why don't you guys go ahead and try those. Okay, once you're done, go on to the next part of the video. All right, solve this system. Now we're going to graph a quadratic. We're going to graph a line. The line, I'm going to have to get in y equals. So that moves over. That's y equals 4x plus 1. Okay? That's a quadratic. I'm going to start with the line. 1 over 1, 2, 3, 4 up. 1 over 1, 2, 3, 4 up. 1 left, 1, 2, 3, 4 up. 1 left, 1, 2, 3, 4 up. 1 left, 1, 2, 3. All right, something like this. All right, and that one's not great. Okay? Now, for this, okay, do what we did in the last unit. Okay? Parent function's x squared, so 4, 1, 0, 1, 4. Okay, solve what's on the inside. That'd be 3. So that's going to be 3. The interval 1 divided by 1 will be 1, so this is going to be 4 or 5. 2, 1. What's going to happen with the y values? I'm going to add 1, so that's 5, 2, 1, 2, 5. So 1 over 5 up, 2 over 2 up, 3 over 1 up, 4 over 2 up, 5 over 5 up. So this is what your graph looks like. Okay? And the solution to that system's right there. That would be 1, 5. Okay? All right, let's do another one. This one, I would just need to move that x over. That's y equals negative 1x plus 2. All right, that's from subtracting x. Okay? All right, so I'm going to graph that. 2, that's 1, 1. Down 1, right 1. And I'll go up this way. Okay? I want a really accurate line. Okay? This, same parent function. Okay? Solve for the inside, that's going to be negative 2. So now it's going to be negative 1, 0, negative 3, negative 4. Okay? two things are going to happen. Times negative 1 plus 6 because of that negative there. So that's negative 4 plus 6 would be 2, negative 1, 5, 6, negative 1, 5, negative 4, 2. Okay, so negative 4 over, 2 up. Okay, negative 3 over, 5 up. Negative 2 over, 6 up. Okay. Negative 1 over 5 up. 0 over 2 up. So this is what your graph looks like. So in this time, it crosses in two spots. That coordinate would be 0, 2. This coordinate is negative 1, negative 2, negative 3, 5 up. So both of those is the answer because they both intersect in two spots. Okay? Let's do another one. This one, I'd have to add 6x over to the other side. That's 3y equals 6x minus 27. Divide by 3. I get y equals 3x minus 9. Okay? So that's here. 1, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. Okay? 1 over 1, 2, 3. 1 over 1, 2, 3. 1 over 1, 2, 3. Okay? All right. This one, same parent function. That's the quadratic. Okay, solve the inside, that'd be 4. The interval would be 5. I'm sorry, it would be 1. Okay, I'm going to do times 2 minus 5. Okay, so 8 minus 5 would be 3. 2, negative 3, negative 5, negative 3, 8 would be 3. All right, 2 over 3 up. 3 over negative 3 down. 4 over negative 5 down. 5 over negative 3 down. Okay. 6 over 3 up. Hold on. I think that's correct for that one. Oh, sorry, this should be 2x minus 9. That's the mistake. It should be 2x minus 9. Yeah, that's where I made that mistake. I was wondering why my points were all off. Okay. I think my quadratic points are right. There we go. And then this one would go like this. Okay, so my intersections are here and here. Sorry about that. 6 over 3 up. 1, 2, 3 over, 3, negative 3 down. Okay? All right, sorry about that. Didn't divide that correctly. Go ahead and try those on your own. Okay, now we get to the quadratic ones with the inequalities. Process starts the same. Okay, solve the inside, that'd be negative 5. Okay, I'd have no interval, so this would be negative 4, negative 3, negative 6, negative 7. I would want to multiply by half and then subtract 7. So that's 2 minus 7 would be negative 5. A half minus 7 would be negative 6.5. That'd be negative 7. That'd be negative 6.5. Okay, and that would be, wait, hold on. Yeah, 2, negative 5. Yeah. Okay. All right. So I got negative 7 over, negative 5 down, negative 6 over, negative 6.5 down, negative 5 over, negative 7 down. Okay. Negative 3 over, negative 5 down. Here's what my graph looks like. Okay. Now, here's the difference. When you have this and this, you're going to make a solid line. When you have this and this, you make a dashed line. So in this case, I'm going to make a solid line through those points. Now, if it is y less than or equal to, you shade basically below your minimum. or below the minimum or maximum. If it's y is greater than or greater than equal to, you shade above the minimum or maximum. Okay? So in this case, okay, because I got less than, I would want to shade below here. So what this does is it goes all the way out like that. That's how the shading goes. Okay, let's say I have this. Okay, there's no inside, so this is going to stay here. Multiply by -1 and add 8. Okay, so -4 plus 8 would be 4, 7, 8, 7, 4. Okay, so -2 over 4 up, -1 over 7 up, 0, 8, 1, 7, 2, 4. Okay, now, since there's no thing underneath this, I would want to do dashed. Now, since it's greater than this maximum or minimum, I want to be on this side of it. Okay, and that's the shading. If it was less than, it'd be in between it. Okay, you guys go ahead and try those. Okay. All right, now, a system of these. So what you want to do is make 2 quadratic graphs. Okay. Okay, so for this is, say this is graph A, and this is graph B. Okay, all right, so what I would have to do on this one, solve that, that'd be 1, nothing, the interval's still gonna be 1, so I'm gonna add 3 to these, so that'd be 7, 4, 3, 4, 7. So -1 over 7 up, 0, 4, 1, 3, 2, 4, 3, 7. Okay, now, this one would be dashed. Okay, all right. And so for this one, this is what you want to do. I would be shading in here. So I'm just going to put that arrow there because that's going to tell me where to shade. This one, this would become -2. So that would be -1, 0, -3, -4. Let's subtract 1 here, so that's 3, 0, -1, 0, 3. Okay. All right. So -4 over 3, -4 over 3 up. -3 over 0 up. -2 over -3 down. Okay, -1 over 0 up. 2 over 0 over 3 up. Okay, so now this would be a solid line. Okay, now on this one, I'm shading over here. Okay, so what I want to do is I want to figure out the intersection of these. Okay, so as you can see, this in here, okay, and this here. So this area right there would be my inequality. And the idea is that any number that you would put into here would make both inequalities work. Okay, let's do this one. Okay, we should get real good at the parent function for quadratic. This one, nothing's going to change here. This I'm just going to add 1. That's 5, 2, 1, 2, 5. So -2 over 5 up, -1 over 2 up, 0, 1, 1, 2, 2, 5. Now this one, okay, all right, let's make sure I have the right line there, yep. This one is going to be a dashed line. Okay, and now this one I would be shading here, so I'm just going to do this action, just so I know, okay? All right, now for this one, this is graph A, graph B, so we'll go A, B, okay? Okay, Okay, now, inside that now is -5, okay? So that would be -4, -3, okay? This is -6, -7, okay? The only thing that's gonna happen here is multiply by -1. That's -4, -1, 0, -1, -3, okay? So -7 over, -4, wait, that's not, yes, that's right. -7 over, -4 down, -6 over, -1 down, okay? -5 over 0 down, okay? All right. Then -4 over, -1 down, okay? -3 over, -3 down. Now this one would be a solid line. And this one, okay, I'm shading here. So where's my solution? All of this area, all the outside area, that would be considered a solution, okay? All right, 0, yeah. Okay, so like for instance, if I picked like 6, 0, if I put 6 in here, that'd be 36, 6 squared would be 36 plus 1 would be 37, all right? 0 is less than 37. If I put 6 in here, okay, all right, that is 11. 11 squared is 121, but a negative there makes that -21. So that's why that area works for both inequalities. So we want to shade outside there. Okay, so why don't you guys, all right, try those, all right? And that is your inequalities for quadratics and solved by graphing with systems.